My name is Gesita Gunawardana.
My name is Niranjala Tilakaratne.
We are so thrilled to have all of you here today on this webinar organized by ACEET and AMT. We are finding ourselves in unprecedented times, aren't we? And a lot of us find ourselves communicating exclusively at home, virtually right now, whether you are a virtual communication novice or you have been doing this for years. We know that you're going to find this webinar helpful not only for immediate situation right now, but well beyond. We hope it's really positive and impacts your career in a great way.
Today we are pleased to welcome the Dean of the Faculty of Technology, Dr. Buddhika Chaitilaka, the Head of the Department of Electrical and Electronic Technology, Kumarage, Head of the Department of Materials Technology, Dr. Naveen Dharmagunwardhan, Honorable Speakers, Mr. Nidershan Suguneswaran, Mr. Rasanga Silva, Mr. Amita Shehan, Mr. Rohan, and Miss Deeptika. We are so glad you two could be here today to share your insights on 3D modeling with SolidWorks. Now, without further ado, I am honored to invite the Dean of the Faculty of Technology, Dr. Buddhika Chaitulekar, on behalf of the Departments of Electrical and Electronic Technology and the Materials Technology.
All right. Good afternoon, all. Hope all of you can hear me. Um, yeah, so first of all, thank you very much for the two associations, Electrical Electronic Technology and the Materials Technology, two associations for organizing this webinar. And also on behalf of the Rajarata University, I would like to warmly welcome three speakers, Mr. Nidershan Suguneswaran and Mr. Rasanga Silva and Mr. Amita Shehan. So welcome you all for the Rajarata University. And I think today's webinar will be very special one and also important one because we know the 3D modeling is an area where it's relevant to everybody regardless of your expertise. You might be an electrical electronic person, or you can be a material person, or even in a mechanical or civil person. Regardless of your specialty, the 3D modeling will be useful. And also, if you talk about SolidWorks, it's one of the most popular softwares among the 3D design softwares it has been using for a while around the world. So I hope today we'll be able to see the capability of that particular software and also the application. So looking forward to have a very fruitful session. So I would like to wish you all the best for your session. So thank you very much.
Thank you, Dr. Buddhika Chaitulaka. Now I would like to invite Dr. Pubudu Kumarage, who linked us with ACECAM Private Limited, Head of Electrical and Electronic Technology Department of Technology Faculty, to deliver his address.
Okay, thank you, Gesita, and good afternoon to everybody. And thank you, ACEET and AMT clubs for organizing this event. First, I must extend my thanks to Mr. Rohan also. Mr. Rohan contacted me and asked whether is there any possibility to organize this kind of a seminar. And I then right away contacted ACEET because ACEET Club has been organizing these kind of events number of times. So I think they have done a great work so far. And this webinar also, they will do a great job and they will enable the participants to get the maximum out of it. If I tell something about SolidWorks, first I got the chance to use this software in 2007, long time ago, that is SolidWorks 2006. And if I look at the capabilities of SolidWorks now, it is enormous. Earlier, we were able to do only 3D compound modeling, 3D designs. Now you can do modeling of entire factory floor, and you can combine electrical modeling as well. So the capabilities are there, they are enormous, and it is up to you to learn it. And one more thing about SolidWorks, it was earlier in before 2010, it was kind of a luxury only dedicated for mechanical engineers. And then um, electrical engineers, electronic and telecommunication engineers also use this software. And nowadays, everybody are using this software. For example, if I mention about one of my students in my final year project group, he had already, before I tell him, he had already modeled everything in SolidWorks. It is a kind of a software now which has the capability so that you can learn it by yourself. If you have some kind of a good introduction, then you can take it onward and learn it. And I think from these webinar sessions, as I know you have organized another set of webinar series to learn this software, and you will get a good understanding and you will get the maximum out of this. And thank you again for organizing this event. And without wasting much time, it is over to you.
Thanks for the enlightening, sir. Now I would like to invite Mr. Navod Sandeepa and Mr. Udesh Buddhika to do some introduction behalf of ACEET and AMT.
Thank you, my friend Nirmala. Good afternoon, all of you. I will hope all are hear me. My name is Nav Sandeepa, a committee member of the ACEET. The ACEET is a professional association of the Electrical and Electronic Technology Department at Rajarata University. This was formed in 2019 as one of the first association under the Faculty of Technology. At ACEET, we set our mission to disseminate knowledge among our young generations. We believe that our community is eager to absorb modern knowledge, so we try to provide nothing but the best of our community. We also believe that if we need to be successful as the undergraduates, we need a strong link between the related industries and the organizations. That way we could be well prepared for future career pathways. Actually, technology can make a powerful contribution to learning if it is used in a meaningful, informative, and credible curriculum. Today, there is a mutual focus on enhancing students' success and integrating technology as a tool. The Zoom, MS Team, and learning management system are prime example of that. In the past, we contributed to our cults at our university by organizing various events such as Arduino Essentials, PCB designs, IoT webinars, and etc. Through these extracurricular activities, we managed to gain more and more experience and positive feedback too. But after the pandemic, we had to leave behind our old ways of doing these physical activities. The current situation around the country and the world is challenging. So we decided to accept that challenge and do our duty to the community. The good news is that we are contributing even more by using online methods. All our credits go to the present technology. That is our dream as ACEET. Today, we are going to learn about highly professionally and industrially used software platform. This knowledge we are about to gain today will positively influence our careers in the future. So I will not take a more time from you, and I will invite my friend Desh Buddhika to continue this presentation. Thank you all for listening to me.
Good afternoon, everyone. Thank you, my dear friend, Mr. Navod Sandeepa. I am Udesh Buddhika, the committee member of AMT. The Department of Materials Technology aims to empower students by giving them the skills and knowledge required to succeed in the modern industrial environment. We strongly believe in the need to complement theoretical knowledge with hands-on skills to produce a well-rounded and technically competent graduate. Metallurgy, ceramics, polymer are the main theoretical and practical subjects that we are following under our material degree program. Now we have 4 batches. Then we have organized workshops, industrial visits, and complete a lot of mini projects under the Bachelor of Materials Technology degree program. Natural rubber slippers with Ayurvedic properties, water filtering machine, invent tile by using natural stones and by using bamboo. So those are few mini projects that we have completed with using our learned knowledge about materials and technical skills. And actually, we also have the good opportunity to experience actual industrial implementations through industrial visits and workshops that organized by our department in Rajarata University. And I privilege to thank all the guests, those who are take part from different industries to help and advise us. Thank you very much for your kind cooperation. And I would like to invite, I would like to share my microphone with my friend, Mr. Kisite Gunwardhan.
Thank you, Mr. Nawad Sandeep and Mr. Udesh Buddhika. Here are now our guest speakers, are well-qualified engineers from ACECAM Private Limited and well-experienced resource persons in CAD industry. Please welcome Mr. Nidershan Suguneswaran, Mr. Rasanga De Silva, and Mr. Amita Shehan.
Thank you so much. So before starting the event, so let's invite our technical sales engineer Steve to give you the brief introduction of our company and the associations we are making and the services which we are provide. So over to you, Steve. So now you will be able to share your screen so you can start.
Okay, am I audible? Hello?
Yes.
Yes, you're audible, but can you please switch your screen? So we are seeing your presenter mode. So
Sorry?
we are seeing your presenter mode. So could you please switch your screen to the presentation?
Is present preview.
Yeah, now it's fine.
Okay, great. So first of all, good afternoon to everyone at Rajarata University, and special thanks for Dr. Bhutika Jatilekar and colleagues for providing us this day to conduct this program for students at Rajarata. So let me introduce you to our today's program. This program is This program is a 4-day workshop. As the first day, we'll be sharing with introduction and demo for mechanical and electrical part. I'm Steve, the technical sales engineer. I'm here on behalf of Mr. Rohana. So he'll be not be able to attend today's event. So I'll be introducing you to our company profile, and Mr. Rasanga, our mechanical engineer, so he'll be giving you introduction about SolidWorks, and Mr. Nidershan, our application engineer, he'll be doing a demo based on mechanical CAD, and Mr. Amita will be conducting electrical and electronic engineering design part as well. Saying this, so you may know us as a SolidWorks 3D CAM simulation reseller and education partner. Perhaps there's more we would like to share with you. So let me welcome you to our ACECAM Private Limited profile. let me give you a brief introduction about our company. So we as ACECAM Private Limited, a prime engineering software solution provider operating in Sri Lanka for past 60 years, providing advanced engineering solutions in the field of mechanical and manufacturing and civil and architecture, electrical and electronics, design analysis, and asset management. We ACECAM Private Limited proud to say we serve over 100 companies in the industry in different industries such as automotive, aerospace, electronics, mold tools and dies, machinery and construction. We got global partners which are Dassault System, Zuken, SOLIDCAM, and EZWCAT TOMS. So together we focus on core competencies. We grow our business every year. So you may know us as ACECAM as a solution provider, but we also provide services. So introducing you into our machinery services. So we ACECAM Private Limited specialize in high precision CNC machining of parts and components, assemblies tailored to customer requirements, whether their order is simple or complex. We also provide services for 3D laser scanning and reverse engineering, and 3D printing, 3D product designing and detailing via using our portfolio CATIA and SolidWorks. We also provide mold flow simulation for our customers. Why not take a tour to see our center, so then you will have a better idea about our company. So let me give a small introduction of Dassault System, who you may know as the product of SolidWorks which your university currently use. So Dassault System stands for 3D Experience Company. We have about 11,000 passionate people across the globe that are at the heart of the company. A large and R&D team connected across 34 laboratories delivering simultaneously combined software for our 3D experience solutions. Dassault System has the large PLM market share with 1,070 customers in 12 industries worldwide. A fundamental aspect of 3DS is partnering with clients who are leaders in their own industry segments, typically leaders in innovation and on the cutting edge of technology in order to answer tomorrow's market needs. Our ecosystem of 3,500 selected partners increase our collective knowledge. The one of our customers and their customers in areas of sales and services, software development, education, and social development. Over 200 companies develop software complementary to our own. The composition of our shareholders has been consistent since our introduction on the stock market. The majority of the company is owned by Dassault family and company management. This stability enables a consistent long-term strategy and long-term investment, enabling to be one step ahead of competition. Saying that, I would like to introduce you to our 3D compass and about our Dassault System product. So, on left side, you see SolidWorks for simple CAD design and simulation, and CATIA for advanced tool design and manufacturing. And you see BioVia for biological students and companies who are related. And actually, I have to tell this that it has served as a best solution for this COVID situation as well. And we got GeoVia for people who are related to mining and construction related. And it also has served for a large number of industries who are related to construction mining areas across the globe. At the same time, I would like to introduce you something really a good tool for which is provided by Dassault System, which is the Simulia product. So it's for advanced simulation. So earlier you might have heard this solution as the abacus, but now it's not limited to abacus. So it's as divided into large number of solutions. So starting with eyesight, FESF, and Tosca and Abacus. Those are the new products that have been come up with the industry. And this is for mechanical simulation, fluid simulation, and also it provides support for students who are related to electrical and electronic for electromagnetic studies as well. Saying that, I would like to request Nidershan to take on the next session. Thank you.
So thanks, Steve. Thanks for the introduction. So let's jump on to the today's session. Let's hope my screen is visible to you. Okay, thanks. Thank you, Steve, for giving the basic introduction of ACECAM Private Limited and how we are catering to the industry and how the Dassault system works in the entire world. So today's session will be let's break down the session. So how we are going to proceed this session. So entirely we are planning around like 4 to 5 sessions. We are planning to give some in-depth knowledge on SolidWorks modeling. So that's the main goal. The sessions, and today's session will be a basic introduction session where I'll give a basic introduction on how these SolidWorks products works and how this design industry works. So that part will be done by me, and then so we have Rasanga. Rasanga is also a student like you from University of Ruhuna. So he's doing his final years, and so he's in internship program, and then later our application engineer Amita will join you, and he will be showing you some electrical design. So that's how the today's session is planned, and so when it comes to SolidWorks product or Dassault system products, so if you go to the industry and if you check out the big names, so most of the companies currently using SolidWorks, one of the SolidWorks products. So if you can see from the portfolio, so you can see that most of the big companies are using SolidWorks products. You can start from the garment sector or the apparel sector, from the MAS and the iDrumany and all the other companies. And then when it comes to rubber industry, so we have DSA, Samsung, and Trelleborg meantime. Sorry. All these companies were included, and then when it comes to automation and also and likewise, so we have like a number of companies which we are currently using SolidWorks products. From this, so you may ask like why we are focusing this session to these students. So that's the big issue. So when we trying to communicate with the industry, and we got to know that though they are willing to adapt the new technologies and the new softwares to their production environment, but since they have some lackingness of skilled people, so that's the basic issue that they are facing. So rather they are facing some reluctance to adapt the technology, but they are ready to adapt the technology, but we don't have enough skilled labors for them, or skilled employees for them. So we thought that we need to eradicate this issue from the root level, so that we choose all the university students. So from starting from University of Moratuwa, Peradeniya, Runa, and all the engineering faculties and other faculties, those who are related to the engineering fields, and especially like technology faculty. So we are trying to cover all these faculties and try to give these basic SolidWorks designing knowledge. So when they pass out from the university, so they can directly go and join the industry environment. So nowadays, so we are not strictly following our 2D hand sketches, so the AutoCAD drawings. We are transforming into a new generation of manufacturing environment. So you might heard that industry 4.0. So where the machines come together and they communicate between themselves, and they try to increase the productivity of the product. So this is how the modern things work. And now if you take think about these universities and the technical institute, those who are using SolidWorks, so you can see most of the government universities are currently using SolidWorks products. Meantime, some of the leading private universities also currently using SolidWorks as a product. In to mention that all the apprenticeship training institutes and the vocational training institutes, currently they are also using SolidWorks. So we wanted to be, though all the universities were currently purchased and they are using the SolidWorks, but we have some limitations around teaching the SolidWorks to all the students. So that we thought like we jumped into the action and we try to fulfill that bridge. So before that, so if you heard about this term SolidWorks or the software called SolidWorks, you might think that it's a 3D mechanical software, or we call this as a CAD software. CAD software in the sense it's computer-aided designing, where we use the computer to design small components. This was so 20 years before, so SolidWorks was a mechanical 3D CAD software, but later onwards we try to adapt the other requirements of the production environment or the product development environment. So then from the design perspective, then we move on to the verification. So verification, where we try to do the simulation in the sense like we try to mimic the real world application within the SolidWorks or our software environment. And then once these two are completed, so we are able to give some enough viable product. But though, so in order to maintain those files, it's a very complicated task when it comes to a very big company. So every day they have to deal with like thousands of documents. So how they can deal with those design documents? So for that, so we are providing a file management platform, and then the communication tools where once you completed the design, how you are communicating those information to others. It can be a customer, or it can be a shop floor engineer, or it can be a machinist. So how you are communicating these message to them. And then later when it comes to the manufacturing stage, in that manufacturing stage, how we are catering in the inspection level and the CAM part. CAM in the sense it's computer aided manufacturing. We use these 3D models, and from the 3D models we try to generate G codes from the model, and we use SolidWorks CAM for that. And then if you want to give a basic introduction of how big SolidWorks is, so currently we have 5 million users around the globe. So this is the one of the largest user base software in the 3D modeling environment. And then if you take the customer amount, so we have around 430,000 corporate customers all around the world, and we are active in 80 countries around the globe with the single passion of delivering the good design. So if you want to like put some lights on this stats, so as I said, like we are currently having 5 million plus worldwide users, and meantime, so we are having 430,000 corporate customers. When it comes to student side, so we have around 2.5 million students who every day in colleges and universities, they are using SolidWorks, with over 30,000 schools and universities are currently utilizing, from starting from MIT or Caltech. All these universities currently using the SolidWorks app. And then when it comes to these already pre-built 3D models, so those are the customers who, once they completed their model, so they are displaying their product in our display website, so which called 3D Content Central, where they have display their 3D products. So let's say when you started designing a product, and from that for the product you understand that it requires a certain motor, let's say electric motor. So then you Google it and you come to know that this brand has this kind of 3D electric motor. Then you can just go to that site and you can search that motor model and you can get the 3D model. Because in 3D modeling, in the sense, we are interested in modeling our part, but not in the others part. Like if the manufacturer can design that one, so we can utilize that and we can focus on our main design. So that's the easiness. So here we have around 1.3 million active users around the globe. And then when it comes to the user groups, we have more than 276 user group around the world with 16,000 active members. And meantime, another important thing is SolidWorks always emphasis on certificating the students. So students or the uh, industry employees. So because the main reason was, so everyone can learn the software, but so we have to make sure that everyone can perform up to a certain level. So that they have introduced certification in 3 levels. First one is associate level, and then we have professional level, and then we have expert level. So we are expecting all the students should be able to complete at the associate level certification. So if you are a SolidWorks, if your university is a SolidWorks user, and then if it's in the subscription model, then all the students can get the free certification. So everyone can sit for the certification and they can obtain the certification. So that certification will be valued all around the globe. So wherever you go, you can take the certification, and it has a verification code. So wherever you go, so you can verify yourself that you are capable of doing certain modeling things in your SolidWorks environment. And then, so nowadays we are mainly rely on social media platforms. So that when it comes to Facebook and YouTube, so Facebook, we have around like 1.5 million followers, and in YouTube you can find around around 9 million YouTube videos. So that YouTube video views. And then meantime, so we have around 150,000 active forum members. Why I am telling you all these stats? Because like if you want to learn this software, and if you go to the internet, and if you have any come across any issues, so if you just put it your question in their forums or a Facebook or in YouTube, so it's a very high chance of getting your answers within a couple of minutes. So even if you are not able to get the answer from the forums, and we are here to help you, and you can send us your queries to us. And so that we have a dedicated team of engineers and other experts are available here. So we are 24/7. So we are working and we are trying to enhance the production performance. And when it comes to the industry vertical, so like once you have completed, so everyone have their own dream, or everyone have some plan to work in these kind of a particular industry. So I'll just give an introduction of SolidWorks. So how SolidWorks is penetrated into the market, and what are the industry verticals which we are currently covering. So starts from the consumer products. So all these consumer product, like it can be a normal plastic product, or it's a high-end luxury products. So most of the consumer products were designed through SolidWorks. And meantime, the industrial equipments, where they supply equipments to the industry and life sciences, especially in medical science. So during this corona time also, so we have given free license to those who are innovating, so those who are improving the medical devices. So we have provided some free license for them to uh, boost up their ideas. And then when it comes to process and plant, so in that area also we have a very good footprint. And then when it comes to construction industry for a certain level, so in basically in structures and all, so we are catering to the market as well. And then when it comes to high-tech electronics, all these modern devices and also which currently utilizing one of the CAD software. So but in entire world, so we are the market leader for this CAD solution provider. And then when it comes to manufacturing, so manufacturing industry also we have a very good footprint. So even in Sri Lanka, so we have around 40 to 50% manufacturing industry is currently using SolidWorks as their daily driver, so 3D CAD software. And then when it comes to alternative energy or green energy, like solar, wind, and also those industry also currently utilizing, and engineering services and automotive and aerospace industry. So like if you have any idea on, so this is the industry which you would like to go and work on, so that's a good chance that whatever the industry you are step into, that company may use SolidWorks as their key 3D modeling software. And then I would like to give you a basic idea of how this design works in modern days. So first I'll explain the typical way how the design works, and then with the modern software help, so how we can enhance that performance. So this is the basic idea which we need to convey, because without a CAD software we can do a product, so there is no problem in that. So you can do a 3D normal product without a CAD software, but we are saying that if you are having a 3D CAD software, so what would be the advantage in typical days? How they started a product or project design. So initially they will start with a conceptual idea, and then they will be having some primary ideas. So they will put those ideas and they will try to create a concept. So from the concept, then they will move to the design stage. In that design stage, so there are many ways that we can approach the design. So nowadays it's not the design is not isolated to a certain engineering area. Like let's say, so earlier days, if it is a mechanical design, so it's completely a mechanical equipment, and then if it's electrical equipment, so it's a electrical equipment. So likewise it was categorized, and we call that as a tossing over the wall technique, where the mechanical design part will be completed and they will just hand over the design to the electrical part, and then they will come up with the electrical part and they will put together, and they sometimes they might come to some problems and they try to rectify the issues. This is the typical process how they do it. So once they finalize that one, then they go for the design validation, where they will create some 3D prototypes. 3D prototype in the sense like they will create some physical products. So then once they completed the physical product, and they will check the physical product in physically. So it can be one of the way that to test the physical product. It can be a destructive test. Sorry, it can be whatever the testing method which available there. So if there is a failure, then they will again go back to the electrical or electronic or a mechanical design, and they will find out that design, and again they will produce another prototype. So once until they get the satisfactory results, they will do this iterative process. So once that's done, so your product is completed, then they will move on to the technical communication part. So this is the key part. So though being an electrical or electronic or mechanical engineer or a designer or a conceptualizer, so you can do whatever you want. So the imagination is like unlimited, like, so you can put whatever the idea you comes to into your mind, and you can do a good design. But if you cannot communicate it well to the production or communicate it with the customer, so you won't be able to succeed in that product. So that's the technical communication plays a very crucial role in here. In the technical communication, it can be a assembly instruction manual, or it can be a 2D normal drawing, or it can be once the product is completed. So for a customer, you can do a technical specification document or a manual. So these all comes under the technical communication. So that part has to be created. So once the product is ready, they will take some photographs. So they will do manually disassemble, and they take some from photographs, and then they will prepare the documents for the technical documentation. This is how the normal typical process works. Once all these things were completed, then they go for the manufacturing. That can be a batch production, or it can be a massive scale production, or it can be a very small quantity production. But they can jump onto the manufacturing, and the meantime in the manufacturing they have to maintain certain quality. So if they are going for a standardization, so they have to obey that criteria, or else if I am producing a product and if I want to set a benchmark for that product, so we need to maintain certain quality. So that part also need to be done. So this is how the normal serial type process works. And now we'll see, using these modern technologies and these softwares, so how we can shrink that timeline, and meantime by shrinking these times, so how we can get benefited. so that initial part, the conceptualization part will remain as it is. And then when it comes to the mechanical and electrical and electronic design, now we have integrated all these environment together. So if you take SolidWorks, so SolidWorks, we have three solutions. We have SolidWorks CAD, so SolidWorks, you can use it for the mechanical design, and we have a SolidWorks electrical. In SolidWorks electrical, you can use it for the electrical design, and SolidWorks PCB for electronic design. So all these design softwares were completely integrated. Like if I want to give a sample, simple example, like let's say one person is designing a electronic PCB, and the mechanical guy is designing an enclosure for that. So once that electronic guy has decided in a certain place, I want to keep the fastener hole, and he kept it and he sent the design to the mechanical engineer. So in mechanical engineer's design, so he figured out that so this place is not suitable to have the fastener hole, and then he can just send him a comment that so this is not suitable, so is there any way possible that we can change the hole. So then they can negotiate in the CAD level itself, they can negotiate and they can finalize, so where the final hole has to be placed. So in the typical serial process, so there is no way that it can be done. So what they will do is mechanical guy will finish the design and electrical guy will finish the design, and then they will come to a table and they start to discuss on that design. So that's the typical normal process. But nowadays process in the CAD level itself, so they can collaborate it and they can figure out the best solution. So once the design is completed, and then as I said, like we will be going to the prototyping stage. So we are in the prototyping stage. In earlier days, we do a physical prototype and we test it out. But in the modern age, we are not doing a physical prototype. So instead of doing a physical prototype, we try to do a virtual validation. Virtual validation in the sense, if I want to give a good example, so nowadays most the car crash test, first initially they will not conduct from the physical model. So once they will completed their CAD model, so they will simulate that CAD model and do the crash test, and from that results, and they will try to understand what are the major issues and what are the major consequences. So then they try to rectify it in the CAD level itself, and then they move to the production level. This is how normally works. So if I take the example, so you all know that car brand called Honda, right? So in Honda, so they are currently using the Dassault system products to validate their vehicle models. So they have they are able to achieve around 95% of reliable results, like what they're doing in real and what they are doing it in the virtual world. So they are getting around 95% correlation. So that it's a so that software says that it's very reliable too, so that you can use the same tools, so which is also available in SolidWorks itself. So you can design a product and you can test it out. So let's give you some examples. So what are the tests you can carry out? So let's say you have designed a mobile phone, and then you have to check whether the mobile phone will break, so if it's fall from your hand, so then you can test it out in the virtual environment and make sure that it's not breaking, or it's not creating any catastrophic damage, and you can work it out in the CAD level, and then you can go for the final design. And the next part is the technical communication. In the technical communication part, where as I said earlier, so once we completed the product, then only we start to create these technical communications, right? So but in the modern age, we are not doing like that. So once the CAD model is start, we have like come to a certain level in the CAD level, so CAD model. So we'll start to generating 2D drawings. Then we start to develop the assembly instructions or product manual, or sometimes we try to capture the rendered image, or else we can call it as sorry, we can call it as realistic photographs. But yeah, you can use your CAD model to create a realistic photograph, and using that photograph you can start doing your marketing activities. Yeah, before you start manufacturing the product, you can start doing the marketing activities. And then like, so once you generate the enough leads or pre-orders, so then you can you have the time to manufacture the product meantime, so both requirements will meet in the same point. So yeah, you can before the product is ready, you can we can gather the customers as well. And then moving to the final part, then we will be having a manufacturing facility, and we have to maintain a certain quality standard. So by doing it in this approach, so we will be saving a lot of time and the cost, and we will be obviously we will be increasing the product quality as well. So when it comes to industry, so if the company or if an entity is not innovating enough, so they will not be able to withstand in the market. So we in business terms we call it as marketing myopia, where so if the company is not keep on innovating, or if they are keep on enhancing their product, so they will not able to sustain in the market, so they will fade away from the market. So because of using these kind of tools, so they were able to reduce the time and they can save some money. So then they can use the time and cost to do some innovation, so where they can sustain in the market. So this is how the modern product development process works. I guess now you guys get a basic idea on that. So if you guys having any questions, so feel free to stop me and you can ask, or else if you want to ask any questions, so you can unmute your mic, or else you can drop it in the chat box, so I'll be more than happy to answer the questions. So the previous slide we were discussing about how this modern approach work, and by doing this modern approach, how we can save the time and how we can save the cost and how we can improve the innovation. So when it comes to our Dassault system solutions, so I'll just introduce the brands. So which are the brand you can use it to enhance these areas. So that's the basic idea of this introduction. Okay. So in SolidWorks, we have a concept called like 4-quadrant concept, where we are trying to cover the entire world. In the right top corner, you can see a compass. We call it as a compass, and it has 4 quadrants, right? So in that 4 quadrants means, so first the left side quadrant, which means it's the it's the 3D designing area, where as our technical sales engineer mentioned, so there we are having our SolidWorks and CATIA, GeoVR and BioVR. So these kind of 3D model creating software, where we try to create this 3D virtual model. And then in the opposite side, in the right side, so we have intelligence, where we can communicate this intelligence. So nowadays we are using machine learning and big data, so we have ample of data, so we try to gather from the data, we try to extract useful information. So we are covering that quadrant as well. And the top quadrant, so we are having the swim community, or we call it as it's a socializing platform, where we bring all these communications together. So in a single world, so we have incorporated 4 different aspects. One is 3D modeling aspect, and then information aspect, and that communication aspect. And the bottom, so we have V plus R in the sense it's virtual plus reality. So we try to connect virtual environment and the real environment. So as I said, like this kind of virtual testing all comes under the V plus R category. So in that V plus R category also, now we have extended our support to virtual reality and the augmented reality as well. So before modeling your product, so you can use HTC or whatever the headset you have, virtual headset, VR headset you have, so you can get the experience of the real product, so directly from the Dassault system softwares. Okay, so now when it comes to these in the initial design part, so in that design part you can utilize SolidWorks CAD for mechanical design, and SolidWorks electrical for electrical design, and SolidWorks PCB for electronics design. So today we will be covering these 2 categories, like SolidWorks CAD. So Rasanga will be showing you a basic idea of like what 3D modeling look like, and then Amita will give you little deep introduction on electrical, so that three tools can be utilized. And in the concept development or in the modern days normal 3D modeling, so we have uh, nowadays we have some cloud tools available, so for industrial design and conceptual design. So these tools were already embedded in cloud. So yeah, it doesn't matter in the future, it doesn't matter whether you are having a good performing PC or a bad performing PC. So if you unless you have internet connection, and if you're having a whatever the device, it can be a mobile device or it can be a normal laptop, so you can just log into the internet by giving a username and a password, and then you can start modeling. So so in the future, so there is no dependency on your computer performance, so it's only internet connection and a basic computing device. And then when it comes to the VR part, as I said, like this virtual verification or simulation, we call it simulation. So in that simulation, we are catering into three major segments. The first segments we call it normal simulations. In that simulation, we try to simulate this static pose. Let's say you have designed a certain component, and you have to make sure that whether this component can withstand a certain amount of load. So that kind of test you can do it, or if you want to do a crash test, you can utilize this. Or if you want to do a drop test, you can utilize this. Or if you want to do a frequency analysis, you can use this. Or if you want to do sorry model test, so that also possible. So all these simulations can be done within our SolidWorks simulation environment. And then if there is any fluid involvement there, so you can go for flow simulation. In the flow simulation, if I want to give a basic introduction, let's say you are designing a car or like go-kart, or it can be a Formula One car. So if you are designing a car, and then you have to make sure that whether the car's aerodynamical performance is it's good enough. So then if you want to do this kind of testing, so you should have $1 million investment, and you should have a wind tunnel setup where you can test out your product. But in the SolidWorks flow environment, where you can create your virtual wind tunnel, and you can test out your product. Or else, let's say if you are developing a YAR file, and then if you want to test it out, you can do it. Or if you are designing a, let's say, agitator or mixture, so like you want to do a latex mixture, so you have a rubber and you have a semi liquid rubber, and if you want to mix it, and then you can utilize the software, and you can verify that the mixture will work perfectly on it. So these kind of things can be done within SolidWorks flow. And then finally moving on to the plastic section. So if you take the real world, so mostly 80% of the products were made out of plastic, right? From that around 60 to 70% of the plastic products used injection molding as the production method. So they use molten plastic. So they inject into a certain mold, and they cool it down, and they will get the solid part. So that's how the injection molding works. So in that injection molding, so if you are designing a plastic product, so when it comes to this injection molding and plastic products, the mold is highly expensive. And like even if you want to do a basic mold, so it will be cost around like $10,000. Even for Sri Lanka, it will be around 15 to 20 lakhs rupees will be costing. So if that mold is not working according to your needs, so it's waste, right? So waste of money. And then again, to repair the mold, you have to spend then thousands of dollars again. So in order to avoid that, so once your product is ready, you can do this in the virtual environment, and you can make sure that, so okay, so this is my product. So if this is the injection molding parameters, then I can get the final product as I want. So then you can do that kind of simulation within the SolidWorks environment. And when it comes to, so all these tools will comes under design and the design validation part. So SolidWorks electrical, PCB, and this simulation, all three capabilities. And then when it comes to technical communication, in technical communication we have tool called Visualize, where it acts as a camera for your product. So once you have completed your product, so you can apply the real appearances. Like let's say if you have designed a plastic product, so you can just drag and drop a plastic appearance, and you can see like how my final product going to be look like. So whether this is what I'm looking for or this is not enough, so then you can do the minor tweaks and you can get the final product out of that. So then from that you can generate a photorealistic images as well. So using that photorealistic images, you can just, as I said, you can do your marketing work. So in real world, so that's how they work. Like they, once they finalize the design, they use this tool to get the final product photographs, and they start working on the marketing activities. And then we have another nice tool called Composer. In the Composer tool, where we try to create these kind of a PowerPoint or a interactive manual kind of things. So we are in mostly, so how the students are doing is like even other university students also. So they use SolidWorks to create the 3D model. So once they have completed model, so when they want to present the model to the panel, so what they do, what they're doing is like they get some snapshot from the SolidWorks software, and they will put it in the solid PowerPoint, and they will show it to them. But if you are doing it in a parallel manner, so let's say if some other students is doing the presentation and you are doing the SolidWorks design work, so in parallel manner, so then if the person who is doing the design part, so if he changes something, then again that person who is making the presentation, he have to change the entire slide. So he have to delete the images, and again he have to get the snapshots, and again he has to do it. But using a Composer tool, so it has a direct connection between your SolidWorks 3D model and the that the presentation sort of thing. So then it has automatically connected between these two. So if the design guy, so if he makes any changes, so it will automatically propagate to the Composer environment, and then the person who is doing the presentation, you don't to have any burden. So if he changes, it automatically changes. So that's how that Composer tool is work. It's completely integrated tool. And then there is another tool called e-drawing. So e-drawing in the sense like it's a tool where you can view your 3D model in your mobile device or a virtual device. So the mobile device in the sense, so once you have completed your 3D model, you can save it in a certain format. Then you can view it in your mobile phone or a tablet or any other operating system platform. So it's available in the cross platforms as well. And then meantime, so in e-drawings, we have enabled AR and VR support. Then you can use one of the Google so VR headset, and you can use it and you can get the real experience. So let's say if you have designed a building, then you can give that e-drawing app, and you can, if he has a Oculus or HTC headset, so you can get the immersive experience. Or else if you have a design a very small product, it can be a very small product, but even though he can have that interactive virtual experience using this app. And then we have a draft site where we still use some certain level of 2D drawing. So in order to do cater that environment, we have another tool called draft site. So finally, when we are moving to the production or manufacturing and quality control. So for the production, so once the 3D product is ready, so in order to make that product manufactured, so you can use many ways. So as I said, it can be injection molding method, or it can be a casting method, or it can be a sheet metal method, or it can be whatever the method you want, you can utilize it. But if you want to manufacture these components using CNC in the sense, it's kind of a basic codes. So we give that basic codes to the certain machine. So according to that machine codes, so machine will automatically move when it cuts. I hope you all know what is CNC is. So it's opposite to the 3D printer. So 3D printer where we adding the material, in CNC, normal CNC milling machines where we are removing the material. Same principle, but it works in opposite way. So we are adding material, we are here we remove the material. Both utilizes G code. Even using your SolidWorks, once your design is completed, you can directly generate your 3D printing code as so you can generate the milling code as well. So once this is completed and you have the code, and once you have manufactured, so then you have the CAD initial ideal dimensions and then your final dimensions. So you can cross check these dimensions and you can generate report and you can analyze these manufacturing processes using SolidWorks inspection tool. And then another tool we have called SolidWorks MVD. MVD in the sense it's model based definition. The basic idea of using this tool is to like try to avoid that 2D drawing usage. So as I said, like in industry 4.0, so we are the machines going to be communicated with themselves. So in that era, so 2D drawings will be not valid, right? So nowadays also, if you create a 2D drawing, so we need some person to interpret that into a 3D environment. So that part is lagging. So that we have created a solution where model based definition where we store all the data in the 3D model itself, so that it will be easy for the employee to read, and it will be same time it will be easy for the machine to read the data as well. So in future you can expect that in every shop floor there won't be any bundle of files. Instead of files, they can have a small tablet, so where they can load the model and they can get the information. So that's how that tool works. And finally, in order to communicate all these things or connecting all these things, we have solutions called PDM and PLM. So PDM, where it's a project data management, or we can call it as a product data management. So in for a certain project, for a certain product, so we can how we can manage the entire uh, tools and documents. All these can be maintained under this tool. And then meantime, so we have another tool called PLM. So PLM, in the sense, it's a product lifecycle management. So these are the generic terms. So it's not only related to SolidWorks. So if you want to get to know that what is PDM, so you can just Google it and you can say it. Like it's not only for SolidWorks or a Dassault system. It's a common term. So for a common approach, how these industries handling their data. PLM is a product lifecycle management. We are from the concept to finally once the product is going to the garbage. So how we are going to manage the entire spectrum. So that's where tool comes into play. And then we have one part or Excelite. So these kind of tools, or another we have NetWipes, and these tools will be helpful to process the data, or it comes under the intelligence part. So this is how these product portfolio works. And I just wanted to say another thing. So in the Dassault system, we are the only solution provider. We are providing a platform as a service. Like we are the only one who giving a dedicated platform for the manufacturers. So you might wonder, like, what I mean by platform in the sense, you can think of Google or Facebook or Amazon. So where you have a username and a password. So let's say you have a Google Gmail account, or you have a Gmail and a password. So once you can using the Gmail account and a password, you can log into a system where you can handle your email, where you can handle your files, where you can handle your photos, where you can handle other stuff, or you can create some third-party accounts and you can handle those accounts as well. Likewise, for that, for your personal needs, you can have that kind of platform. So you in industrial needs, so we have created a platform where the design starts, and how we can design, how we can validate, how we can manufacture, how we can inspect them, and how these data can be managed. All these things can be done within a single user login. So that's what we call it as a integrated design platform. So the SolidWorks, the Dassault systems, the only solution provider which provides this sort of a service to the industry as of now. So as a summary, so now I think you all got some basic idea of actually what are the SolidWorks products and how this design works, and in that design phase, so what are the tools can be utilized. Because so most of the university students, they have universities have purchased SolidWorks, but mostly they got to know that SolidWorks is a 3D CAD product, so they will only focusing on that 3D modeling part. So but we have like uh, other tools as well, so they are not like really exploring those tools. But in industry, so they have purchased the tools, but we as I said, like we have some lacking of these skills as well, so that if you can like brush up those skills in the student level, so it will be very helpful. Because in the future industry will be like moving more or less like more towards the skill based industry rather than depending on your qualification. So in the future the degree doesn't matter, but your skills matters. So if you can polish up your skills, so that will be easy for you to beat the others and get the job. So as I said, like in the mechanical designing environment, we have three categories where you can start off with the part modeling, where you can do a basic part, and then from that part you can do a assembly. So yeah, you can get many parts and put together, and you can see how this assembly going to look like in the final product. And then from that you can create a 2D drawing as well. So Rasanga will walk you through in that, so how basic 3D model can be created, and how 2D drawing can be created, and then how we can do a basic assembly. And electrical part also, I don't want to dive in deep, but the Amrita will give a basic introduction on that tool. But before that, I'll just give a basic idea. So if you're like, let's say if you are doing this enclosure design, and also if you are doing the mechanical part in the enclosure design, and he has designed all the sorry all these other components, and then you need to do the routing. So for the routing, then finally you have to get the cut list of these wires, right? I'm just giving a simple example. So for the cut list of the wires, so when the normal process, we don't know how long these wires were required, right? So in using these softwares, you can get the easily you can get the bill of material. We call this bill of material, where it listed all the required amount of material. So from that you can just go and purchase the wires. So you are not going to purchase more, you are not going to purchase less. So you will on point, so you know like how much wire you want exactly. So that kind of advantage is there. And then in design validation segment, so we are, as I said, like we can cater for the structural simulation, and then if the fluid is involved, you can do a flow simulation, and for the plastic area you can do a injection molding simulation. So these are the main validation tools which we have, and because using these tools, so number of real prototypes will be reduced. So earlier if they make 10 prototypes, now they will make at least, so they will make one or maximum two. So between one or two uh, prototypes, they will be able to get the product ready. So then in the communication part, so we have tools like Composer, where you can create, as I said, like as a student, so you can try it out instead of doing a PowerPoint presentation of your next design. So you can utilize your 3D CAD model, and you can create that kind of a PowerPoint sort of environment using a SolidWorks Composer. And then, as I said, like SolidWorks Visualize, it will act as your camera for your SolidWorks model. So once your model is completed, you can just imply drag and drop some appearance, and you can get a feel of like how this product going to be look in the final output. So that kind of uh, in the visual aspect, so you can get a better idea from the visualize tool. And then we have MBD, as I said, like we just wanted to eliminate this 2D drawing part, and we need to move to a 3D model environment. So rather we don't want to spend time on 2D drawing, so we can directly store all the information on the 3D model. And then finally inspection tools, so we try to automate the documentation or the quality monitoring part. So these are the basic tool which is available. And for the finally for the data management, we have PDM and PLM, as I said. So it will handle the project data management or product lifecycle management. So as a summary, so as I said, like SolidWorks, it's not a single solution. It's only focusing on CAD. So it's a completely integrated platform. So that's why the most of the customers in the worldwide, it's a well-recognized product. So even if you take Sri Lanka in the corporate sector, so we have around more than 80% of market share. So like let's say almost all the industry is using SolidWorks. And when it comes to if you want to learn or if you want to explore the SolidWorks portfolio, and then we have ample of support in the community as well. So even now we are trying to in the process of creating a local student community where we are doing this project as a CSR, and we try to connect all these students in Sri Lanka. So now the students were scattered, and like every university is isolated. So we just wanted to create an environment where all these design interested students can come together and they can solve their issues by sharing their thoughts. So that's kind of a process is currently happening. So once we try to get your information, and from that we are trying to build that sort of collaboration between the university as well. And then we are planning to organize this kind of a CAD designing contest where we can they can design a product and they can manufacture it, and they can see like what are the barriers or what are the practical inefficiencies that they are facing. And then from like as I said, like the certification also we would like to like emphasize among the students. So as I said, like in as an initial stage, we are expecting all these. If the students can be certified as a associate level, then they can like move on to the other levels as well. Like in the associate level, currently around Sri Lanka we have like around 3,000 plus certified users. For the professional level, we have around 1,000 plus users, and the expert level only we have 4 users. So I think like in the future we can like increase these numbers as well. Okay, so let's by saying that, so let's hand over the session to Rasanga. So Rasanga, as I introduced him, so he is also one of the final year student from University of Ruhuna. So he's a mechanical engineer. So he will be walk you through basic components. I will walk you through how to design a basic component using SolidWorks. So this is not a tutorial session. So we'll be just doing you a demonstration session. So how you can do a design. So from that you all can get a basic idea of how these 3D design works. So then if you are interested, you can participate in the future sessions and you can get benefited. So that's the main aim of the first session, because not all the students were interested in 3D modeling and designing. So we just wanted to filter out so those who are interested in 3D designing. So then we are trying to collaborate with the other university students, so we can put together in a same environment where you all can learn the 3D modeling. So that's the plan. So he will be walk you through us in how a simple CAD model can be designed, and how that can be assembled. So the floor is over to you, Rasanga. So before that, like we'll have 1 or 2 minutes. So if you guys are having any questions, you can shoot your questions so that we can answer the questions and we can move on, or else we can directly jump onto the session. So we are expecting your questions. So while if you want, you can share your screen. So is there any questions from the student side? So seems that because like this is the first session, so yeah, if you have any inhibitions, or like if you are having any interest on 3D modeling, but all these days if you have like kind of a dilemma, like you don't know that how to approach it correctly. So if you have any kind of that kind of a question, so you can ask here and you can clear it out. So because from the next session onwards, we will be directly diving into the software, and we will be modeling, and we will be designing things, so that if you have that any doubt, so that you can ask from us today. So in the later session, so we will be mainly focusing on the designing part. So since there is no any questions, so let's hand over the session to Rasanga. Rasanga, over to you.
Thank you, Nidershan. I think you can hear me. Can you hear me?
Yes, yes, you're audible.
Yes. This is, I think, also you can see my screen. This is a completed, almost completed design of resonant volta, and I'm going to complete the remain part of this resonant volta. There is a missing part in this area. You can see. I'm going to insert knuckle part for this area. For that, we need to open the new part from here. Okay, I will take the top plane to sketch, start my sketch. I'm here, take the origin as to start my sketch. uh, I will give the dimension as outer diameter as 120, and inner diameter as 65 millimeters. And I'm going to extrude this part through plane to 125 millimeters. Okay. Then I take front plane to continue my sketch other parts, and in front plane I will draw this remain part. The dimension of this part is it also 120, and inner diameter also 65, and I will extrude this sketch also with 150 millimeters, also with mid plane. Uh, and also I need to give this dimension as 160. Then I will go for front plane again, sorry, top plane to complete the other part. Before that, before start this sketching, I need to construct a construction line to continue the other parts. Center line, likewise. Then I continue the sketch. This should be parallel to other line. Okay. I'm going to mirror some parts using this center line. Okay.
Then I will give dimensions. This distance is 90 and remain dimensions are complete. Okay, now I'm going to extrude this sketch also using midplane. The distance would be 120. Okay. I will choose only this area to extrude. Okay, then I go to front plane, sorry, top plane again to cut some parts. The dimension should be 70, and also this line and the center line of this sketch should be I will give the dimension as okay. I'm going to extrude, cut this part as extruded. Okay, I think you can see my part, but there is a extra part in here. I'm going to delete this part. Okay, I'm going to add some fillets for this design. Okay, so this is the toggle part. So I have some other parts to complete this 3D model. So I'm going to add grease fitting port for this part, and for that I have to use my saved library. You can see from this right corner there are some saved library components in this box. I'm going to use grease fitting port for this 3D model. We can at this part and add this likewise. I will give this distance as 65 millimeters. Sorry, 62.5. Okay. This is the completed 3D model, but there are some other parts to add this model. Before that, I'm going to save this model. I will name as this part. Before going to assembly part, I'm going to break this part into 2D drawing. For that, I have to open a new part for drawing. Okay, this is the drawing. We need to add the part that there is. Okay, this is the 2D drawing of that I designed. You can see there are all dimensions in this drawing, and there is a cross section also in this right view, and this is the isometric view of I designed 3D model. There is a detailed view also in the about the grease fitting port, and I am going to go to the assembly part to complete the knuckle part. For that, I have to go to the assembly part. In that file, I'm going to add the knuckle. Okay, and I'm going to library and add for this part. First, I'm going to add flange bronze bearing to this design part. For that, we need to deck the part, and you can see we can assemble the part easily, like this, top and bottom. You can this fitting how fitted with the design part. You can see the cross section of the 3D model. This is how the assemble two separate part in assembly file. I'm going to continue other parts. I'm going to add expander pin for this design. For this, I'm going to choose long 220 millimeters long pin. In here also, I can make a mate between this inner diameter and outer diameter, and I'm going to add a width mate to make center this expander pin. and I'm going to add another part, wearing plates for bottom and top. So that also we can drag the part likewise. Okay, I'm going to add another expander pin for front area. For that I choose 150 long expander pin, and I'm going to give another mate to center the expander pin. This is the final part of that we designed, and we have to another part to insert this 3D model. This is the remaining part. Sorry, that we need to add. I should give a mate for these surfaces. Okay, this is the completed 3D model of knuckle, and I'm going to insert this completed 3D model into our receiving bolt completed design, so that before that I will take the remain another part to complete the assembly. So I'm going to insert that designed knuckle part into this area to connect between this and this. So I'm going to insert that component using this. So not this one. I will have to save that. Okay, and I'm going to give a mate between this surface and this one. Okay, and I'm going to give a mate, another mate between this surface and this surface, and I have to give another mate between this surface and this inner diameter. Okay, likewise we can complete our model. So after completing this model, we can go to the our completed resuming bolt design in here. That automatically updated that we added part to here. You can see this is my this is what I have drawn in my 3D model drawing part. So this is how demo going on in this software. I will give chance to Amita to continue other parts in this session.
Thanks, Rasanga. So he showed us like a very good in-depth basic introduction on how these parts can be modeled and how they can be bring into a assembly environment and put it together. So you can see like he was with us for a past like two or 3 weeks. So within the 2 weeks time, so he was able to like master the software. So that learning curve is very small. So by saying that, so we got two questions. So let's answer the questions from Chamika. So he was asking like whether we need to fully define the sketches. So it's absolutely very important that every sketch needs to be fully defined. So when it comes to, so even for a normal design it's fine, but if you are manufacturing it, so if you want to make manufacturing that part and it has to work properly, then all these sketches would be fully defined. But when it comes to these curves and also, then you have that freedom, you can keep it under defined. But uh, doing all these sketches by by fully defining those sketches, it's the best practice. But some scenarios, there are some scenarios, but we may not able to fully define the sketch, but that scenarios can be ignored. But mostly for manufacturing, we totally rely on this fully defined sketch. And then there is another question from Gihan, saying that he just wanted to try some engine. He wants to model a engine. So is there any website where he can find the 2D drawing? So Gihan, like mostly you don't get these original blueprints from the manufacturers because most of them are patent. So you won't be able to get the original blueprints. So if you have some books, you can refer to that. So in the old machine design books, they have some blueprints on it. So in the old engines, and then even still, if you want to have some blueprints, you can just Google it and you can get some. There are some blog spots. There are some like third-party creators. They have some. They have just uploaded the produce some amount of 2D drawings. We can utilize that. But if you want to like entire engine drawings, or if you want to gather all the 2D drawings, I don't like, it will be around like 300 to 400 drawings. So it will be a very massive number. So when modeling, so we will be simplifying those designs over there. It's better to just Google it and get some simplified 2D drawings, which is available in mostly in the blogs. So in printer. So if you go to GrabCAD, so in those websites, so you can find simplified engine models or 2D drawings. From that you can start building your basic engine design. But if you want to like full detail design, I don't think you will be able to get it through the internet. Is that clear? So okay, so is there any other questions regarding the 3D modeling part? So it's just a basic introduction, so make note of that. So we just wanted to give you that this is how this 3D modeling is works, right? So if you are interested in this kind of a workflow, then you can give it a try. So that's the basic idea uh, of giving that a short demo. So you guys having any other questions, so you can drop it in the chat box, or you can unmute your mic. So while I'll hand over the session to Amita, so while he's doing so, if you guys having any questions regarding the CAD model, also drop it. So once his part is finished, so we'll address the questions.
Okay, thank you, Nidershan. So a very good evening to you all. So today I'll be doing a quick walkthrough through the SolidWorks electrical. Today I'll be designing a small conveyor system. Okay, so actually in SolidWorks electrical, we can start a project in two ways. One is starting a new project, and the other one is by unarchiving an existing project, or it's something like a template. So today I'll be doing my demo by archiving an existing one. So actually SolidWorks electrical, it has much capabilities compared to other ECAD softwares. Like SolidWorks electrical has the capability to create faster schematics with intelligent tools that are available. and rapid searching for symbols and components using filtering options. And another one is automated numbering and report error checking using DRC, design rule checks. And okay, so I'll rename my today's project as demo. And I'll keep these details as it is. And if you want, you can change them as. Okay, so I'll. Okay, so today I'll be more focusing. Actually, today I'll be focusing on 2D schematics. Actually, SolidWorks electrical we can go up to 3D level also, as Nidershan explained you earlier. So okay, actually. Today's industry is multidisciplinary, which means electrical, mechanical, electronics engineers, both all the teams, all the members work together as a team. So if you are in electrical side, it's better you. It's good if you have fluency in SolidWorks electrical. So okay, by double clicking on. Okay, so before start our demo, I'll give a brief introduction about the user interface. So on your on the top, it's our ribbon menus, and on our left hand side, it's documents pane, and in this middle section, the it's called graphics zone, and the bottom right corner, it's the status bar. So I'll start my power drawing in this power drawing. So for that, I'll use draw multiple wires, and I can select what are the phases, and I can make selections using these checkboxes. So I will select only all the 3 phases and the protection, and I can simply draw my cables, and I can bend them without clicking, and I can check whether it suits their likewise. But today I'm not going for a complex one, so I'll keep this one as it is. And I can actually, as I mentioned you earlier, SolidWorks has much more intelligent tools. So let's assume I want wires horizontally, which is connected to these 3 lines. So what I just have to do is I just have to click on this phase Y, and I can just take my mouse over to the right side. So it is automatically connected with other phases as well. Now I'm going to add a few symbols for my power drawing. Actually, there are 2 ways to add a symbol. One is from this side panel, and other one is using this option in our ribbon menu. So today I'll be actually I have created a group them for today's session. Yeah, you need see as I okay. See, when I'm going to drop this one in the middle of a wire, and there are some portion outside also. So when I drop that one, it asks me a few. It pops out a dialog window. Sorry. So in that one, I can make few changes related to my project. So, and also I can assign manufacturer parts as well. So I'm going to search for a manufacturer part which is available in my libraries. It has, as I mentioned you earlier, it has rapid search for symbols. So actually, since I was searching for a manufacturer part for a motor, it has filtered me all the 3-phase motors which are available in the system. So I can change the manufacturer over here, and I'm going to search a component just by typing the reference. So I'll be using this motor, and as you can see here, the state it shows as a green color, which means these connections are compatible to be made. So I'll select that one. Just by pressing OK, it has automatically, I think you earlier saw that there was some portion of cable on my right hand side from these connection points. The system has automatically trimmed those extra wires, and it has given this symbol a name to M1, and it has given all the details about this motor as well, since I attached a manufacturer part for this one. So actually this device, this symbol is marked as 2M1, which means it is in second page, and M1 denotes motor 1. Likewise, since this power drawing is the second drawing in our project. So, and I'll quickly add a few other symbols that are required for today's session. I will assign manufacturer part. Sorry. We'll add a contactor to power power up the motor. Here we can see there are two extra. Here in blue color it shows there are that is which means they are extra, but even though now it seems to be extra, but in our demo, as we move on, we will use those two connections as well. I'll add a 4-pole disconnector. Over here. I will assign a manufacturer part for that one as well. Okay, so, and also I want to add a DC power supply for to power my control diagram. For that one, I'll use macros, which means and so actually macros is a place that we can save regularly used items that are used more recently, and which means we can save them for our future use. So I'll use this one, which is a to D converter to supply 24 volts for my control circuit. Okay. Now what I'm going to do is I need to make these wires numbered. So for that one, I'm going to number new wires. See now all the wires are given a number, but here we can see that ground wire is not given a number. So what we have to do is we have to change the properties of that one. So I will change this equipotential formula. Okay, now let me number the wires. Okay, now the wires are numbered accordingly. Now, what I'm going to do is I'm going to add a few terminal strips for this motor. I will add the manufacturer part for this one as well. I'll give OK for all terminals. Then what I'm going to do is I'm going to edit this terminal strip so that now what I'm going to do is I'm going to assign a cable core, which means actually there are 4 cores. So what I'm going to do is I'm going to assign a cable which consists of this 4 cores. So I'm going to right click on that one and go to associate cable cores. Since no cables are available here, I'm going to take a new cable. So I will change size, standards and types. I will select this 14 gauge wire. So I will select all these items and this one. I will give associate cable cores. Okay, now we can see a cable is assigned which consists of 4 cores inside it. And also here the wires are numbered as W1-BK, black, brown, likewise. Okay, so our power dropping is almost complete. So let's turn to our control circuit. I'm going to draw my control circuit, so which 24 volts using 18 gauge cable. I'm going to add few command buttons. So first I will add a normally closed push button. Okay. Now I'm going to add a normally open push button. I'll assign a part later for that one. So here now as I mentioned you earlier, I told you that I'll be using that extra 2 connections from this contactor coil. So I'm going to take that coil from this one. This relay coil, so that once I press the push button, this relay coil will be energized, and it will so that it will cause to power up the motor. So what the in here the question is, the problem is the coil will be energized only when this push button is pressed. So for that to as a solution, I'm going to latch this circuit using the other extra part, connection from this contactor. So I'll use this normally open contact, and I'll place it over here. I need to delete this part. And this part. Yes. I'm going to add a indicator for this line. Okay, now but now this but there's no it doesn't seem any difference between the positive rail or the negative rail. So I'm going to change this line for the ground to ground. Style and I'll replace the Y style. I'll change it to, I'm going to propagate it through the equipotential line. I'm going to select control ground for that line. And as we can see, the whole equipotential line is turned to be green, which means it's the ground wire. And by keeping this diagrams like this, it doesn't make any sense for a external user or someone. So what we have to do is we have to make connection between pages so that they can understand from where the power comes to where power goes likewise. So actually, I used this 24 volts power supply to supply power for this control circuit. So I need to show to where this power flows. To do so, we have to use this origin destination arrows. So what I'm going to do is I'm going to do a single insertion. So this will be the origin and the destination will be the control drawings, this port. So first I'm going to click on this side and then on this side. So we can see it shows 03-2 and over here it shows 02-4. What does this mean is this one connects to the third drawing second row. Here we can see the row is 2 and here it says that 02-4, which means the power comes from second page, fourth row. Okay, so I'm going to add another insertion for this ground as well. Okay. See, now I'm going to close this one and my control drawing is okay. Okay, here we can see the contact list of the contactor that we have used. Okay, so this is actually a very short introduction to the software. Actually, this is so we can go up to create a 2D layouts, and I will show you how to that finalized project since the time is running out. Okay, give me a few seconds. I'll show you how a final project will look like in a 2D drawing, 2D cabinet layout. Okay, this is how it looks like after we create design the 2D schematic, sorry, the cabinet layout. So here's the 4-pole disconnector. These are the breakers and likewise. And finally, what we can do is we can export our project into PDF files after creating several documents such as the bill of materials grouped by manufacturers and list of wires by line style likewise. So for example, let me show you this page. Here we can see, okay, so here this one. From SWST, we need several items likewise. So the description is given and likewise. So we can know how much quantity we need and the manufacturer, all those things. After completing all the tasks, we can export this as an to different file formats. So now I'm going to show you how to as a final to print it out as a PDF file. I will save it on desktop. Name it as demo. See, it is from the beginning, it gives us the dropping list, and actually this one is actually what I showed you is a simple from this simple version from this project. So we can create to export as a PDF file as well. So I think it's the over. It's over. The session. It's time to over the session. So if you have any questions, feel free to ask.
Thanks, Amita, for the in-depth session. So this is like slightly in-depth session. So he was just trying to introduce the user interface and then how to create the basic layouts, and also in the short span of time. So he was able to give the I guess you all get some basic insight on how the SolidWorks electrical works. So these are two basic introduction which we want to bring it to you guys, and wanted to show that this is how this designing environment look like. And if you are interested, or if you like these kind of work, so that you can join us with the next session, and we can do some good basic designs. I would like to get some questions. So if you guys have any questions, so you can ask the question. And Gautam or Harit, so I have just shared a Google form document. So is it possible for you guys to share it among the students? So it's I just drop it in the text chat window. So if students can fill it out, that's also fine. So if someone can share it to the pass it to the students, so that they can fill it up the forms later onwards. So it's okay.
Okay, sir, sure.
Yeah. Okay. Do others have any questions from the today's session? If there is no any questions, like Gautam, over to you. So we just can.
Thank you for your stimulating session. It was really informative to gain precious knowledge on 3D modeling with SolidWorks. Now I invite my dear Mr. Buddhi Sankalpa to deliver his vote of thanks on behalf of us.
Hello everyone, I am Buddhi Sankalpa, the former president of Association of Materials Technology. Today it's a great experience for us, and it's our pleasure to be a part of this wonderful session. First of all, special heartfelt thanks goes to Mr. Rohan, Ms. Deeptika, Mr. Nidershan, Mr. Asanga, and Mr. Amita, who are the main facilitator in the session from ACECAM Private Limited. Then AMT and ASEET Society members, thank you very much for the organizing this wonderful session. You guys have done a great job. And then I'm grateful for our dearest lecturer and the university for participation in this session. Last but not least, another special thanks goes to my colleagues in the university for participation in this session. Finally, I would like to thank everyone who helped to become this session a great successful one. We hope to continue this workshop in every week, so I kindly invite you to stay with us to elaborate in your knowledge. Finally, thank you all for your participation, and we hope you all had a great time and you learned something from this session. Thank you.
Thank you, Mr. Buddhi Sankalpa. Well, now it's the time for you to share your thoughts and comments about the webinar through the link given in the comment section.
So if possible, so if you guys can share the feedback forms with us as well. So if you can share the summary, so that based on that we can customize the upcoming session. So it would be very helpful for us to customize our future sessions.
Meanwhile, I would like to remind all of you, if you are in tune with ACEET and AMT, you will be able to participate in more valuable events like this because we have got lots of plans for you.
We are grateful for the time and effort you took to share your ideas with us. It was a pleasure to being with you all today. Let's wind up this session and thanks again for joining us. We will see you next time. Thank you all.